So for the microscope lab, I realized that the calculations are very confusing if the data that you have is a little bit messed up. And it's very difficult to get good data because I'm just measuring and trying to see clear images. So what I thought I'd do is give you a set of data to use to do your calculations for this lab. And there will be no penalties if you use the data that I give you. And that way I think the concepts will be a little bit more straightforward and clear. If you choose to use your own data, that's fine as well. You'll get full credit as long as the calculations you do are correct. So it is totally your choice. So if you choose to use the data that I provide, it is here in my table 3 of my experimental data. And so for the 30 centimeter microscope, your object distance would be 6.9. For the 35 centimeter microscope, it'll be 6.5. And for the 40 centimeter microscope, your object distance is 6.1. So I've copied that data here. Just on this Word document so you could see it again a little bit more clearly. And I want to add a little bit more. I want to add that the focal length of your objective lens, which is the lens closest to your object, use 5 centimeters. And for the focal length of your eyepiece, I think you should use 10 centimeters. Those data I think is all you need in order to calculate everything you need to calculate in the lab. So using equation 1, which is 1 over F equals 1 over I plus 1 over O, you will calculate the image distance for each of these objective distances, right? So you'll have 3 numbers. Using F will be at first 5. And then once you do that, then later in the lab you will use this regular linear equation, which is I over O. And then you'll use the angular equation, which is 25 over the focal length of the eyepiece, which we're going to say is 10 centimeters. And finally, the magnification of the scope itself is ML times MA. Okay? So feel free to use these data for calculating the Build a Lab microscope.